All right, good afternoon, everyone. Thank you so much for joining us today for our Connecting with Conductivity webinar. This is a perfect time to be having a webinar on conductivity because it is Water Quality Month. So I am your host, Taryn Picard. I am the US Sales Manager here at Onset Computer. Just to cover what this webinar will be about, it will run for just about 25 minutes. We will try to leave some time at the very end for some question and answers. I would like to stress to you if we don't get to answer your question, please feel free to reach out to us directly. We have a team of application experts that would be more than happy to help you. And also just a reminder, this webinar is being recorded, so you will get a copy of that as well. Little bit of overview of who Onset is. We are a world leader in data loggers. We definitely like to think we're the best of the best. And we are located right on Cape Cod. So that picture right there is a picture of our building where we do all of our manufacturing, our engineering, our sales, our marketing. All of us are right there located in that one building. Of course, at the moment, most of us, like I'm sure many of you are as well, are located at home in our remote office. Today's presenter is Andrew Thompson. Andrew is a sales application expert. He focuses on our water quality market and environmental monitoring applications. And with that, I will hand it over to Andrew.
Thank you very much, Taryn, and thank you everyone for joining this webinar. For today's agenda, it is about conductivity and salinity, but we're going to start off with water quality and an overview on some of the products that Onset offers. Then we will jump into salinity and conductivity, why it's important, why we measure this. Then we'll do a product overview on some of the Onset offerings. Then we'll get into the meat of the presentation, which is really the deployment methods and tips, what to do before deploying, some calibration methods, some mounting options, maintenance, and then we'll end it with some real world applications and then a cool application story that we have from one of our customers. To start this off and to wake everyone up, we'll start it with a poll question. Are you currently using data loggers?
Awesome. And so I've just launched the poll and it looks like, wow, right out of the gate, we're at a 50-50 split. The results are pouring in. Give you one quick second to get your last chance answer in there. Alrighty, we're going to close out this poll and share the results. And it looks like more than half of you are using HOBO data loggers. That's great to see. And hopefully those of you who have never used data loggers before will be so excited at the end of this webinar that you'll start using our data loggers as well.
Great, thank you, Taryn. All right, so to start off, as I mentioned, we're going to talk about a little bit about water quality and why it's important to monitor water quality from lakes to streams and all bodies of water. Really, monitoring water quality is an essential part of keeping our planet healthy and sustainable. You could go as far as saying that water is probably the most important resource on the planet. And also we monitor because changes in water quality can act as a warning system for emerging problems or an alert for existing issues. These are some of the water quality products that Onset provides and offers. The first one being water temperature. We have many different options for water temperature. We have USB options, Bluetooth options, and also remote water temperature options as well. This one here being a Bluetooth option, and this is our tidbit logger. And I do want to make a quick note about this tidbit logger that some of our customers might not know. It has a water detection feature that actually is great for intermittent stream use or tidal areas where the data will actually show you that when this product is in or outside of water when you're monitoring temperature. So that's a quick note that I want to make about the tidbit logger. It is a useful tool in those intermittent stream environments. Then we have the conductivity logger, which we're going to be talking about today. Dissolved oxygen. This is our Bluetooth pH logger. And then also light level. One that's not mentioned on here is water level, but I will get into that a little bit later in the presentation. We have many offerings for water level, and it's a very common application. So why do we monitor conductivity and salinity? Well, since conductivity provides us with an idea of total dissolved salts or ions in water, it's necessary for many applications. You have on the right-hand side, you can see some marine life, saltwater marine life to freshwater and in between as well. And we also monitor for the quality of the water, whether it's tap water or managing wastewater. We also use it for industrial applications to monitor, the content in the equipment itself. If there's, a high content of ions built up in equipment, it could actually damage the equipment. We measure for irrigation for crops. And you can see on the right side key here, these are some of the different levels of conductivity that you may find are common for tap water or fresh water. We also measure for ecological factors in the environment around them, as we just talked about marine life. And then also with other water quality measurements. I have a slide later on in regards to dissolved oxygen and water level and how using a conductivity logger alongside them may be important for your application. So what exactly is conductivity and salinity? Well, salinity is the concentration of dissolved salts in the water, and salinity can be measured, and Onset measures it with our data assistant and in our software through the practical salinity scale of 1978. And Onset will provide this measurement in PPT, or parts per thousand. And we get the salinity measurement through conductivity, which conductivity is the measure or the measure of water's capability to pass electrical flow. And this is proportional to the concentration of ions that are present in water. So similar to salt, the concentration of salts in water is how we get that salinity reading. And Onset provides conductivity in a measurement as microsiemens per centimeter. So Onset offers two solutions for conductivity measurement. The first one being freshwater conductivity. We have this product comes in at $750, which is a great price. It really allows you, that price really allows you to spread your range, and where if you have an area that you want to measure multiple points, the price really comes in handy in that regard. It allows for 3 measurements. It will provide actual conductivity, temperature, and specific conductance at 25 degrees Celsius. There's 2 calibrated ranges, and you would typically choose one of these calibrated ranges, the low range being between 0 and 1,000 microsiemens per centimeter with an accuracy of around 3%, and then the high range 0 to 10,000 microsiemens per centimeter with an accuracy of around 3% as well. The makeup of the product is a Delrin housing, so it will not corrode in salt water. Although this is a freshwater conductivity logger, you may have saltwater intrusion or things of that nature, so it will not corrode in that environment. It has a non-contact sensor with a titanium pentoxide coating to prevent corrosion as well, so it's a very good, well-built, durable product. It has a 3-year battery life at 1 minute logging. So if depending on your logging interval, that could fluctuate the battery life, but at a 1 minute logging interval, you're looking at around 3 years. It also has 18,000 measurement range when using that higher low calibrated range. The second offering that Onset has is the saltwater conductivity and salinity logger. Again, comes in at $750. Just as the freshwater does as well. So it really allows you to expand that range of measurements in an area. Along with the freshwater logger, it provides actual conductivity, temperature, and specific conductance at 25 degrees C, but this will also provide that salinity reading with that practical salinity scale. This has a low and high range calibrated range as well. The low range being 100 to 10,000 microsiemens per centimeter with a 3% accuracy, and then a high range of 5,000 to 55,000 microsiemens per centimeter with a 5% accuracy range. And that's within a 3,000 microsiemens per centimeter range. And I saw some questions about estuary environments, and that's one that I'll touch on, and the accuracy and what you can kind of expect and the length of deployment if you are in one of those environments and it's going to fluctuate a larger amount than 3,000. Again, with the Delrin housing and the non-contact sensor, has the same 3-year battery life with that 1 minute logging, and then also the 18,000 measurement memory range. I will mention that you can use both the low and high range. It will bring down the memory, I believe, to around 14,000 if you are using those. If you're doing a saltwater application that may get into the low range and the high, you can use both. It would just be a shorter deployment or shorter memory. So now we're going to talk about before deploying and the understanding the environment in which the logger is going to be deployed in is important, and it's important for the length of deployment and also for the steps that we take. So using a meter beforehand will kind of confirm those expected ranges for each deployment. If it's a freshwater application, the meter might provide you enough detail to use one of those calibrated ranges to choose. If it's a salt or brackish water environment, this can vary greatly, again, with those estuary environments. Saltwater applications, this range will actually determine the suggested length of deployment and the calibration steps. So if you're monitoring low tide and high tide and you really get a sense of what the low and the high is in that area, it can tell you if maybe this is something that needs to be a shorter deployment or the calibration steps that you have to take. So this is one of the more important slides. It really gets into the accuracy and what we talked about previously on the accuracy with the saltwater logger. This is specifically for the saltwater logger, and you can actually find this. I think there is this the manual for the logger is in the handout section. This is on page 2, and it goes into how the accuracy can change. So I'm going to give an example of that. In a stable environment with the salinity changes below 3,000 microsiemens per centimeter, the accuracy should be better than 5%, as we suggested in the specs. For applications with higher and more frequent changes, number one, you're looking at a deployment that is really no longer than 1 month. You would want to calibrate in the beginning and the end of that deployment, but really, typically, we would, because of the drift, we'd like to keep it within a month. An example, and I could show you on the plot as well over here. An example that I want to go through is maybe similar to an estuary, where a body of water ranging between 36,000 microsiemens per centimeter to 50,000 microsiemens per centimeter, the calibrated point that we would actually want to use for the deployment would be right in the midpoint of both of those. And with that, you'll get your range. So the 36 to 43 and the 43 to 50 is going to give you that 7,000 microsiemens per centimeter range. And from the chart here, you can see that 7,000 would give us an accuracy, and it's expected to be around 6%. So as you can see right here, if you go up and there's a nice little cross reference right there, 6%. So if the change is 4,000, you'd be more around just over 4. And again, that comes with your midpoint in the distance between the low and mid and the mid and high. So that will bring us to our second poll question. And in addition to conductivity, what other water quality parameters are you interested in monitoring?
All right, well, I've just launched the poll, so we'll give everyone a moment to fill out that poll question. And it looks like, wow, we've got a lot of people selecting all of the above, which is very exciting. That's great. And just another second to get your poll results in, and then we'll go ahead and share those results. All righty, so looks like the winner is all of the above. That's excellent, and really great to see a lot of people also looking at monitoring specifically pH, DO, or water level as well. So these are really great results for us to see. Thank you all for your feedback.
Great, thank you, Taryn. It was good to see as well dissolved oxygen and water level, because I do want to touch base on how the conductivity measurements can sometimes go alongside a dissolved oxygen logger or water level for that matter. And I'm going to touch a little bit about Onset's dissolved oxygen logger and our HOBOware Pro software. HOBOware will actually provide a salinity adjusted DO measurement, whether that's one that you've received from a meter or from one of our loggers. You could enter that manual entry, or HOBOware Pro actually allows for you to upload the conductivity logger alongside of dissolved oxygen logger as well to compensate for that entire deployment. So instead of entering just one standard figure, you would upload them together and it would compensate through the entire deployment. This is on the left, you'll see the HOBO U26001. This logger comes in at 1,250. The logger below is water level logger. This is a pressure transducer, a polypropylene pressure transducer, so it can be used in both saltwater and freshwater environments. With water level, salinity can impact the density of water, so it's important to have those measurements as well with conductivity. And the HOBOware Data Assistant, similar to how it does with dissolved oxygen, it will adjust for selected salinity levels. So if you're looking at maybe freshwater or seawater, you can add those or you can select those options, but it will also provide you with the option for manual entry as well. So whether you get that from a meter or from a logger. In areas with rapid changing salinity, unfortunately, like the dissolved oxygen logger where you can upload conductivity with it and it will compensate during that deployment. With the water level loggers, we don't have that same process, so you would have to post-process that data. Again, with the water level solutions, this is the U20L04 from Onset that comes in at $299. We have many options for water level. We have Bluetooth solutions. We have remote solutions for water level as well. So now we'll talk a little bit about calibration methods. These are just two methods that I believe are probably some of the most standard. For stable conditions, taking a reading directly from the water is sufficient enough. So in that environment, you would most likely deploy your logger, allow it about 15 minutes to stabilize, and then you would take your reading with a meter alongside it and log that in your notebook, and you would timestamp that so that you can use it later when you go to offload your data. In an area, again, maybe like an estuary where it's rapidly changing, the conductivity levels are rapidly changing, a jar sample may be recommended. Again, we talked about finding that midpoint for conductivity in your area. So maybe you're looking at the low and the high tide. With that midpoint, that's where we want to calibrate from as well. So when you find that midpoint, what you would do is typically I would assume you grab a sample during high tide, and then you could add fresh water until you reach that midpoint. You would then add the logger, allow it 15 minutes again to stabilize, and then log that in your notebook. And these steps actually should be taken at the end as well when you are finished with your deployment so that you can enter that into the HOBOware software. Some maintenance tips, really we're looking out for biofouling on the sensor. You should clean before each deployment, and that will help to avoid drift or inaccurate readings. And for the cleaning, we use a mix of dish detergent or biodegradable soap and tap water, and use a cotton swab to avoid scratches on the sensor face, so no abrasive material that could potentially scratch the surface and also provide inaccurate readings. So the Onset HOBO conductivity loggers are standalone loggers, so they require a shuttle to offload. We have two different shuttle options. The first one being the waterproof shuttle that comes in at $249. This shuttle does require HOBOware Pro software. However, with many of the water quality loggers, you would have HOBOware Pro software for those data assistants that we provide anyways, so it shouldn't be an added expense to use this shuttle. It has internal memory for on-site deployments, so that's really the key factor between this and the HOBO base station below, is it has that internal memory so that you can bring nothing but the shuttle out to the sites and offload that data and bring it back to your computer, whether it's at the lab or another area. It has an optic USB interface, and it's waterproof up to 20 meters, so you can actually offload your data right in the water without even taking the logger out. The second option is the base station, which comes in at $124. This logger does require that direct connection to a computer. So again, whether that's taking the logger back to your lab and offloading it with that connection, or bringing your computer with you to the site and doing it that way, it does require that direct connection. You can offload a full 64K logger in 30 seconds. That's the same as well with the waterproof shuttle, but that's a very fast offload. And it also has that optic USB interface. So this is a little screenshot of our HOBO Pro Conductivity Assistant. Similar to dissolved oxygen and water level, this is an assistant that HOBO software provides. It will help calculate salinity using the practical salinity scale again, and it will calculate also specific conductance with choice of temperature compensation method. So it will provide that right up here, if you can see. So it will have linear compensation, freshwater compensation, and seawater compensation. Those field meter readings that you had calibrated for at the beginning and the end of your deployment, you would actually enter as well right here with the timestamp, and you would enter those in, and those will also help for, you know, the calibration points will help when it comes to fouling or drift that you may experience. So now a couple tips on and methods on deploying the conductivity loggers. Number one, you want to look for steady flow to the logger itself. That's typical with many of our water quality loggers. You want to look to avoid freezing water. For conductivity specifically, you do not want, or you want to avoid any conductive materials. Metal, for example, you want to avoid that. I think you want to keep the sensor around an inch away from any metals. The sensor always facing vertical to avoid any bubbles from collecting. And also, a lot of our customers will use either protective housing or PVC or ABS wells. Below you can see our HOBO protective housing that we offer. This does work with our conductivity loggers and some of the other water qualities loggers that we offer. And as you can see on the right, these are some of the mounting options that we suggest. Mounting to a rock or a cement slab or a block. The advantages of doing this is it's less visible, so the reduced vandalism, and also it keeps it out of the way of boat traffic or people in general. One note here, make sure you can find them, so use markers, landmarks, or GPS. These are some other common mounting methods. You have a stilling well. This is most typical that I hear is for water level. Actually, this is a typical application or method, as well as a 2-inch PVC slotted PVC stilling well. And we actually offer a Teflon coated stainless steel cable to suspend the logger from the top. And on the right, you'll see actually our protective housing, or the HOBO protective housing, on two different mounting options. The tether mount, which it's attached to, I believe, by zip ties, and then a post mount. Again, with the post mount, just make sure that for the conductivity logger, the sensor is at least one inch from the metal. So here are some areas that you might monitor conductivity. Saltwater bay, and this is for saltwater applications, saltwater bays, estuaries. Estuaries are the most common that I hear of, just because they're rapidly changing with the freshwater intake and the tide coming up. It can really go from near freshwater to, you know, full seawater at any given time. So a lot of our customers that reach out are looking at those estuary environments. Coral reefs as well, tide pools, mangroves. For freshwater applications, you're really looking at pollution events or runoff events such as snow melt, mine discharge, wastewater treatment. So there's a number of freshwater applications as well that you would look at for conductivity. This is we're going to finish this off with a application story from our friends, the Billion Oyster Project. And they are using HOBO conductivity loggers and others, pH and dissolved oxygen as well, for oyster habitat restoration. Here's a little blurb here. Years of over-harvesting and pollution left New York Harbor in despair. In 2014, the Billion Oyster Project was launched. With the help of students, volunteers, and partners, the team leading the Billion Oyster Project is dedicated to restoring oyster reefs in the New York Harbor. Now, why oysters? Well, for one, for water quality reasons. They can filter up to 50 gallons of water per day, which is great. And in addition to their water filtering capabilities, their reefs play an important role in providing a habitat for many species and can help prevent storm damage. On the right-hand side, the lower right-hand side, you can see a picture of one of our conductivity loggers. A little tough to see, but one of our conductivity loggers in the protective housing at Lemon Creek Lagoon in Staten Island. So to help achieve their goal, the Billion Oyster Project, again, uses different HOBO loggers to really map the environments that they're in, salinity being one of them, where they're in a similar estuary or bay environment and it can change frequently. Understanding the salinity and conductivity in those areas is an important measurement. Here's a little quote from their website is, as we install reefs, it is imperative that we test various restoration methods, continuously evaluate our impact, and adapt in response to our discoveries, creating scalable best practices for oyster reef restoration in challenging environments. So they're using these HOBO data loggers to really map the quality of water at each one of the locations. And that's really to provide insight on the growth and the health of oysters, but to also make sure that what they're doing is having a positive impact. So it's good to monitor water quality around that area and see how it changes over time, where it started and where it ended. The environmental challenge of restoring oyster reefs provides researchers and students with an opportunity to use science and explore an ecosystem right in their own backyard. And happy to say that today the Billion Oyster Project team monitors 13 active reefs over 7 acres and has successfully restored 30 million oysters. So that's a great story, and I appreciate them for allowing us to share that with everyone. So that is going to wrap up our conductivity webinar today. And we can kind of kick it over. I'll bring Taryn in to kick it over for any questions.
Great. So if anybody has any questions, over on the right-hand side of your screen, you should see a little question box where you can type in those questions. And I will kick things off with one question we have here is just really where to look for some more resources. And so just so everyone is aware, on our website, there are tons and tons and tons and tons of resources. If you go onto the actual resources tab, you can see that there's also something called the knowledge base. And within that knowledge base, there is information such as sample data that's been post-processed using our HOBOware Pro conductivity data assistance. So if that's something you're looking for and you want to see what that sample data looks like, go ahead and check that out on our website. Again, under resources, go right onto the knowledge base and you can type in your questions there. And let me see here, just pulling up a couple of different questions. Hold on one moment. Andrew, first question is specific to biofouling. Is there any type of preventative maintenance to the biofouling? Do you have any additional components you'd recommend customers purchase if they're in an area that's going to have a significant amount of biofouling?
And you can help me with this, Taryn, maybe. I know some of our products do, like the pH logger and the dissolved oxygen logger, but I do not believe that our conductivity logger has like a protective cap. They can use that PVC housing, but I don't believe we have an actual cap to prevent biofouling.
Yeah, not specific to biofouling. So in a lot of cases, we do sell data loggers that will have an optional biofouling copper guard. In this case, for this particular logger, we don't. We do have a housing that you can purchase. It's a protective housing. It's basically a PVC pipe that has some holes cut into it and caps on each end. Ultimately, that's to ensure that the proper water flow gets around the logger itself, but it does help a little bit to prevent some biofouling, but that's not typically what it's designed for. It's really more designed as a mounting technique to be
And
used in
to
harsh
avoid damage.
environments. Yeah. Yep. Let's see here. If you, let's see, talking about, are there any plans to offer automated data uploads to the cloud in real time? So I will tell you to stay tuned. Do we have any cloud-based conductivity data loggers today? No, but stay tuned. Onsit's constantly working on coming out with new products, especially in the water quality market. We do have a really unique and you know, rugged remote monitoring station that currently can connect water level data directly to the cloud. It also can work with third-party sensors. So if you are using something like the pH Ionics pH sensor, you can tie that into our station and have your water level and pH data sent directly to the cloud. And again, all I can do is say stay tuned. Onsit's constantly coming out with new stuff. So something like conductivity could definitely, hint, hint, be in the near future. And let's see here. Are there any, oops, sorry, we already read that one. Question, Andrew, for you, specific to using the shuttle versus the base station. Do you typically recommend one over the other?
Typically, customers that ask, and this is for any of our standalone data loggers, they typically go with the waterproof shuttle, and that's because of the internal memory and not having to take all your equipment out to site and have that direct connection. So it is very frequent, and like I mentioned before in the presentation too, when you're using water quality loggers, a lot of them has that data assistant from HOBOware Pro software. So you would already have the software. So really it's just that little expense to upgrade to the waterproof logger for that internal memory and to make things more convenient.
Yeah, absolutely. And then just to go back on the biofouling, if you're in an environment where you think that that is going to be a high risk, I do recommend you visit the logger more often to clean it, try to keep that at bay. All right. And so with that, if we didn't get to your question, we certainly will follow up with you, but don't hesitate to reach out to us. At the end of the webinar, you will be sent a brief survey, and I just really encourage you guys to, fill out that survey. Please provide us with your feedback, the good, the bad, and the ugly. We definitely want to hear it from you. It helps us to improve in the long run. And also in that survey, there is a question, would you like to have someone from our application sales team follow up with you? We are more than happy to talk to you about your specific application. Everybody's application tends to be unique, so we can definitely spend some time going over that with you. Just answer yes to that question in the survey, and someone from our applications team will reach out to you.
All right. Thank you everyone for attending. Thank you for Taryn for kicking me off there. I appreciate everyone joining. That was my first webinar, so thank you for joining. And if you have any questions, my contact information was on there as well, and we can discuss further maybe some of your applications and ways to use our water quality loggers.
Great. All right. Thank you, Andrew, and thank you, attendees. Everybody have a great day.